How to prepare samples for metallography analysis. Have you ever wondered how scientists and engineers figure out why materials fail? One key method is metallography analysis, which starts with preparing samples in a very specific way. Let's break down the steps involved in this process. First up is sectioning. This is where a representative piece of the material is cut. The goal is to do this without altering or damaging the microstructure. Low-speed diamond or abrasive saws are commonly used for this task. These saws often have coolant to prevent heat buildup, which can cause deformation in the sample. Once you have your section piece, the next step is mounting. This involves embedding the specimen in a polymer resin, either thermosetting like bakelite or thermoplastic. The resin is placed in a mold to protect the edges and provide a stable base for the next steps. This makes handling much easier during grinding and polishing. After mounting, we move on to grinding. This process is essential for creating a flat and smooth surface. It starts with coarse grinding to remove any saw marks and surface irregularities. Then, you transition to finer grinding stages using progressively finer abrasive papers or wheels. Care is crucial here to avoid introducing new surface damage. Once the grinding is complete, polishing comes next. This step is all about achieving a mirror-like finish that is free of scratches. Polishing typically uses diamond suspensions or pastes on cloth pads. You start with coarser abrasives and gradually move to very fine ones, sometimes down to submicron particle sizes. This step is vital because any imperfections can hide important microstructural details. Now that the sample is polished, it's time for etching. This involves using a chemical reagent that selectively attacks different components of the microstructure. Etching reveals features like grain boundaries, phases, and defects by creating contrast that is visible under a microscope. The choice of etchant depends on the material and the features you want to see. It's best to etch immediately after polishing to avoid contamination or oxidation. Finally, the prepared sample is examined microscopically. This analysis can provide clues about the causes of material failure or mechanical issues. Sometimes, additional tests like hardness measurements are performed to support the metallographic findings. This systematic preparation process is essential for accurately representing the microstructure. By observing features such as cracks, inclusions, and deformation patterns, investigators can trace back the origins of material failures or breakdowns. Proper sample preparation is a foundational step in understanding why a product failed or a mechanical component broke down.